In this next problem on page 84 in your student text, we're going to find the slope and the slope intercept. We're going to figure out what the equation is for the function if we are given a graph. So let's take a look at the problem. You're going to notice that on this graph, our line is going in a different direction. This is a negative slope. We're going to interpret the meanings of slope and y-intercept and why this is negative. Let's read the problem together first. Elena is training for a bike race. She makes this graph to show the relationship between time and distance if she maintains her planned speed. That means that she's keeping at a constant pace and she's going at the same speed. She's not changing her speed. Write an equation for this function. Then identify the slope and y-intercept and explain what each means in the context of the problem. Look at our x-axis. It's always going to be some kind of time, okay? In this case, it's in minutes. Look at our y-axis. It's always going to be a measurement of some kind. In this case, it's the distance from the finish line. So from 0 is the start. As we go higher, our finish line is where she stops. Notice that when we start at 20 miles, and notice as we get closer and closer to the finish line, which is 0, the closer we get, the smaller the distance is from our finish line. Even though we go down in our distance to the finish line, we increase in time, okay? So what's happening here is that as the time increases, we're getting closer and closer to the finish line. So again, look at this graph. It slants downward from left to right, okay? It's going in this direction. This is a negative slope. It happens when the y values decrease and our x values increase. Okay, so this table shows when x equals 0, just like on that graph. What we did was we put this graph into a table. Okay, when x equals 0, my y, my starting point, is at 20. Okay, my y equals 20. That means my y-intercept, where this line on this graph starts, or wherever this line hits my y-axis, okay, that's 0. That's my y-intercept, that's 20. Okay, so wherever my x is 0 and my y hits my y-intercept, that means it's intercepting that axis. It's taking that axis. So it's at 20. Okay? As each x coordinate increases by 20, so every time I increase by 20, my y coordinate decreases by 5 every time I go further. So my slope is negative, okay? So I have this negative sign now in front of my 5. It decreases by 5. Every time I decrease something, it's going to be negative. If I simplify negative 5/20, it's negative 1/4. So now that we formed our table, we can use the information from this table and from this graph to help us to be able to write our equation, okay? We're going to use that equation, y equals mx plus b. We're going to substitute our slope, m, and our y-intercept for b. My b, I know, is 20, okay? Because that's my y. My y-intercept is 20, just like we discussed. And my slope is my rise over run. My rise is my y2 minus my y1. And my x2 minus my x1 will give me my run. So again, rise over run gives me negative 1/4 times x. And that's all I did to form my equation. That 0 and that 20 on the y-axis of this graph, that 0 and that 20 represents the 0 miles from the finish line. The 20 means the 20 miles from the finish line. So we know that this race is 20 miles long. The 0 and the 80 on our x-axis represents the time. That means that the race hasn't started at 0. The 80 means that Elena has raced for 80 minutes. So she expects to take 80 minutes to finish. Number 18 says, fill in the blanks to show the meaning of the slope. As the time spent racing increases, the distance from the finish line decreases. Okay, so on page 85 in our textbook, it should say decreases. Every 20 minutes, the distance from the finish line decreases by 5. So we decreased by 5 in our distance. The slope, since it decreases by 5, it's going to be -5 over 20, because my 0 to my first measurement is 0 to 20. Again, that's my rise over run, or it's also known as 1/4. It means that each minute, the distance from the finish line decreases by 1/4 a mile. And again, my y-intercept is 20. Question after that says, what does the y-intercept mean in terms of distance from the finish line? It means that the y-intercept shows that at 0 minutes, or at the beginning of the race, Elena is 20 minutes from that finish line. Again, that slope, -1/4, that means that for each minute raced, the distance is going to, the distance from the finish line is going to decrease by 1/4 a mile. So going here, getting to here, getting to 0, every time I go, and the more time I have, I'm going to get closer to that distance to the finish line. The y-intercept, 20, shows where I start. That's my starting points of, that's the starting point of my race. So let's try another problem. A storm moves at a rate of 8 miles per hour. It is 200 miles away from Freeport and headed directly to this town. The equation y equals 200 minus 8x can be used to represent this function. Identify the slope and y-intercept and explain what they represent. First off, this is not my slope-intercept form. Remember, my slope-intercept form is y equals mx plus b. So I have to figure out how to rearrange this problem by using my associative property of addition and subtraction in order to make this equation into the y equals mx plus b form. So here's what I can do. I know my y is still there, but my mx is over here. So what I want to do is I want to change it so that I can make it mx, my 8x plus b, and change this into an addition problem. So if I have to change this into addition problem, I have to change from my properties of integers, I have to change my 8x into a -8x, and then I add my 200 at the end. So my problem looks like this. My y stays the same. My 8x is now -8x because I'm bringing that out front. I add my m at the end. I change my sign into addition because now I made my -8x, and I switch it over to 200. Now let's go through the steps of actually figuring out how to solve this problem. First, what is this problem about? This problem is about a moving storm. What is this problem asking me to do? I'm looking for a verb and I'm looking for a question if there is one. Okay, it's telling me to do something, to figure something out with this problem. This problem is asking me to identify the slope and my y-intercept, and it's also asking me to explain in my own words what these numbers mean. What are my facts? I know this storm is moving at 8 miles per hour. I know that this storm is 200 miles away. That my slope is -8. Rearranging my equation, my y-intercept is 200. Now I have to explain what they represent. I know that my y-intercept is 200. That's going to represent that distance that the storm is from Freeport. My -8 represents the change in the storm's distance from Freeport each hour. Okay, so for every hour, the storm's going to move closer by 8 miles. This wraps up our lesson for analyzing linear functions. When we get together in class, we're going to work on identifying slope and identifying y-intercept. We'll practice page 86, 87, 88, and some of 89. Your job is just to study what the y-intercept is and what the slope is. Make sure you read the notes that I posted in Google Classroom. And for this week, make sure page 83, number 1 and 2 in your student workbook, your practice book, is complete. If you want to retake your functions quiz, you must do the remedial worksheet that's posted for functions online in Google Classroom and submit it in class. And that wraps it up. Please let me know if you have any questions or need any help with anything. I am always an email away. Please make sure that you put the LWIN at nguyn at orecountyschools.net into the address bar, and make sure you guys put in a subject and then ask your question.